Hi, this is Professor Cummings, and I wanted to do a video on implicit differentiation. And before I want to talk about start talking about implicit differentiation, I want to talk about explicit differentiation. Now, explicit differentiation is simply what you've seen most of the time, which is just y is stated explicitly as a function of x. Okay, so y is stated almost completely as a function of x. So y equals x squared is an explicit function, and to differentiate this explicitly, you just take the derivative of y and x squared. Otherwise, it's just known as the power rule. So that's explicit differentiation. So it's a very straightforward type of taking a derivative of a function. Now, implicit differentiation, just the opposite. It's not explicit anymore. So you got an implicit function. So the variables can't be easily separated, or in this case, or the way this is written, this definition, a function or relation in which the dependent variable is not isolated on one side of the equation. So you can see with this equation, it's not as easy to isolate x and y. So they can't be done as explicitly. But there is an implicit relationship between x and y. Now, if we want to differentiate that, that will be known as implicit differentiation, and that is just an application of the chain rule. So the chain rule, to take a derivative when one function is expressed implicitly in terms of another. So in this case, y is expressed implicitly in terms of x. And we'll get more into what that actually means. So if we take this definition and show you this equation, so just looking at this, and bear with me on this one, it's implied that y is a function of x in this particular equation. And as we go through this equation, you'll see that when y is taken, or we do this implicitly, you can see that y dy dx is f prime of x, and that is where we get get the chain rule. So what this is you're seeing y as a function of x, or y is equal to a function of x, and whenever we take the derivative of each term in this particular equation, we need to put in the fact that it was done in relationship to x, dy over dx. And that's why you'll oftentimes see everything that's not x has to have this multiplier of dy over dx added in. So let's do an example. Just using this equation here, we'll show you a short example of implicit differentiation. Now keep in mind, whenever we take the derivative of y, we're going to have to tack on a dy over dx. And within this equation, you'll also see the use of the chain rule as well as the power rule. So there are three steps in doing an implicit differentiation problem. One is, obviously, you differentiate, then you collect like terms in terms of dy over dx, and then you solve for dx, which is ultimately what you're trying to do. And with that, we can actually create a mathematical function. So first step in this equation, you're actually differentiating, and this is fairly straightforward. Again, looking at the power rule, x squared is just 2x. This is the product rule, x times y. So we've got x times the derivative of y, dy over dx, plus y times the derivative of x, which is just dx over dx, or 1. And then this last equation is y squared, which, if you consider that's still the chain rule, you've got 2y, and then that's dy over dx times dy over dx. And then the derivative of 1, derivative of 1 over dx, and that becomes 0. So now we've got this equation, 2x plus x dy over dx plus y minus 2y dy over dx equals 0. So that was step 1. We actually went through the differentiation. Step 2, we're going to collect like terms. So that means we're collecting anything, or separating the things with the derivative of x, or dy over dx, from the ones that don't have the dy over dx. So we're going to actually separate those by adding them to bar, subtracting them from both sides. So in this case, we're going to subtract 2x from both sides and y from both sides. All right, so now we've actually done the separation. We're also going to have to factor dy over dx out of this term on the left side, which would leave us with dy over dx times the quantity of x minus 2y is equal to negative y minus negative 2x. Then we go to our third step, which is actually solving for dy over dx. So all that would be is a matter of dividing both sides by x minus 2y, the quantity of xy over 2y, which would leave us with the quantity of negative y minus 2x over the quantity of x minus 2y. And that's it. That is implicit differentiation. Just 3 steps: differentiate, collect like terms, and then solve for dy over dx. Again, this is Professor Cummings. Thanks for watching, and don't forget to go to the engineer's reference for more math videos and downloads that are free. Again, thanks for watching.